Hey everybody, it's Mr. Carr again. Today we're going to be looking at day 2 of our law of sines. We're not going to do any area today. We're going to look at a weird case that happens with our law of sines, and it has to do with an angle that's acute in your triangle. Okay, so what can possibly happen is this. Like this is a kind of rough sketches of all these different diagrams. Let's say angle A is an acute angle inside your triangle. Okay, so potentially can't even make a triangle. This invisible height right here, if that is actually greater than this side that's across from angle A, it's not even possible. It's like creating this little swing pendulum that does not complete a triangle. Let's say that A is equal to exactly that H value. Then we get exactly one triangle because it has to be a right triangle then. Okay, we'll take a look at some of these things that might look like that in the future. One special thing is if we're dealing with this one that actually has two possible triangles here. Okay, and that actually is incorrect. It shouldn't say no solution. It should say two possible solutions. Okay, so because of that, and like that's one of the ones we'll look at a little bit later. The last one here is A is greater than or equal to B. So B value is right here. Here's my angle A. If this is greater than that one, don't worry about it. It's just one possibility. Okay, and that's again, this is acute here. The other weird thing is if you're dealing with an obtuse triangle, okay, or right or obtuse, if you get the side that's across from that is actually less than this side that's adjacent, that's not possible either. So that's actually no triangles there. But if that side is greater than this one, so this side that's across from that angle A, doesn't matter if it's a right angle or obtuse angle, as long as it's greater than this side B that's adjacent to that angle A, then that means we do have one triangle that comes from that. So we're going to look at a few examples where this comes in. So let's start with this one. Determine whether it has no solution, one solution, or two solutions for the triangle. Then we're going to solve it. First thing is it's obtuse. So I just need to double check. This side that's attached to it is 8 is less than the 11. Okay, so what we have here is this scenario. Okay, the side that's across from our angle is actually greater than that side that's attached. Okay, so that makes it one possible triangle here. Okay, well, one possible triangle right there. So I'm going to just go ahead and set this up with law of sines because I have my side and angle pair here. So if I do the sine of 110 divided by 11, I'm doing this one because I want to actually find one of my other angles, in this case, angle N. That is across angle or side 8. So I'll do the sine of N over 8. Okay, so if I multiply both sides by 8 here, we can have 8 times the sine of 110 over 11 is equal to the sine of N. Remember, find the measure of an angle, we have to do inverse sine. So that means if I take the inverse sine of 8 times the sine of 110 over 11, that is equal to angle N. That's what goes in my calculator. 8 times the sine of 110 divided by 11, then I take the inverse sine of that. It says here round to the nearest degree, so I'm going to round it off when I put it in, and I get 43 degrees for N. Okay. Now, to solve the rest of this, angle P is pretty straightforward. I'm just going to take 180 minus the 110 minus the 43 degrees. So angle P comes out to 27 degrees when I subtract those. To find side P is my last part right here. I have to do law of sines again. Now that I have angle P, I can use that. Now, one thing I will mention is in my calculator, I am using not the rounded off 43 degrees. I am using what my calculator found out, which was like 26.8891. Make sure you do that for yourself to be as accurate as possible. I'll put side P over sine of 27 is equal to 11. Oops, 11 over the sine of 110. We multiply both sides by the sine of 27, so I get 11 times the sine 27 over the sine of 110. And again, this is what goes in my calculator right here, using that, not the 27, but it's like the sine of 26.8891. And I get 5.3 as an answer. Again, that's solved because I have all my missing pieces here. I want to quickly talk about these cases here. Here I made very similar triangles, but these are cases that we get no triangles, one triangle, and two triangles from. Okay, I'm not going to solve the one triangle, but I am going to talk about the two triangles, what we have to do for that. First thing is this. What we're saying in the diagram is if I draw this height in, I need to figure out what the length of the height is based on this being a right triangle now. Well, if I do that as the sine of 30 is equal to h over 16, 16 times the sine of 30 will represent my height, which in this case is 8. Well, how is this possible for this length to be 7 and then this height is 8 here? It's not possible. What's actually happening in this scenario is the 7 would come out like this and would not reach and complete this triangle. Okay. This one comes out as exactly 8. So we actually have only one triangle from that. Okay. The triangle is not drawn accurately here, but it's more of a situation like this. It's a right triangle. Okay. With this is 8, this is 16, and this is 30. So it is only one triangle now when the height equals that length. So again, this is not drawn accurately here. This is the more accurate version that gives me one triangle. But with two triangles, what happens here is this. We're getting H is, sorry, give me 1 second here. Sorry about the quick change. Just pull this up because this is what we're showing with this one. H ends up being in between, or sorry, A, the value of that, the side across, ends up being in between the two sides, H and B, or the false side, I guess, H, the height of the triangle, and then the other ones. Okay, so when I do that down here, come back, there we go. Since I've got H is less than A and less than B, because my H I solved was 8, that is less than the 10, but the 10 is less than the 16. What we get is this ambiguous case where it could be two possible triangles. The second triangle is not drawn accurately because here's what the 10 would actually look like. It would actually look more like this. That side's 10, and we get this one right here. Okay. The biggest difference is this creates an obtuse angle at this spot. Okay. So if I do my normal law of sines, I have to keep in mind that this angle here would be two possibilities. So if I do 10 divided by the sine of 30 equals 16 divided by the sine, we'll call it B here. 16 divided by the sine of B. Okay. And I rearrange this a little bit so that the sine of B is equal to 16 times the sine of 30 divided by 10. So that B is equal to the inverse sine of 16 sine of 30 over 10. Okay, this will give me my one possibility of my angle. So then I get inverse sine of 16 times the sine of 30 divided by 10 gives me 53.13 degrees. Okay, but that is if it's an acute. The other possibility is that's obtuse, and what we would get from that is actually going to be 180 minus 53.13. So if I take 180 minus that, that is the other possibility, which is 126.87. So if I have two triangles, I have to solve both of these possibilities. So I'm going to go through the rest of my law of sines using this right here, and I would do that with my 16, and I could find this third angle as well, and then I would use that third angle to find that side. I would also do it the same thing here. Now that I have the 126, I would use that to find this angle, and then I would use that with sorry, this one is 10. I use that angle here with this side here. Okay, it's side C, I guess. So keep in mind, angle B can be two possibilities from this scenario. Okay, so you're going to run through twice in that case. All right, but that is it. We'll see more examples on that on some of our practice, but that is it for today. Take care, everybody.